In this video, we'll talk about linear functions and slope. And I wrote here a few formulas that come in handy. First of all, the slope, which is labeled by m. It's y2 minus y1 over x2 minus x1, where x1 and y1, it's an ordered pair of one point on the graph, and x2, y2, it's an ordered pair of another point on the graph. So just imagine a coordinate plane where we plotted the point A and the point B. The slope, which measures the steepness of the line that passes through AB, is given by the vertical change, so how it changed from y2 to y1, over the horizontal change, how it changed between x2 and x1. Another formula is point slope form of an equation of a line. If the slope is given, I know the value, and one of the points is given, either A or B, any of them, then we can find the equation of the line. So right now, I see the line, this is the graph, but I can actually find its equation using y and x, using this formula that we have here. Another formula would be slope-intercept form, y equals mx plus b, which means if I know the y-intercept, which in this case it's exactly this point, if I know the y-intercept and I know the slope, we can actually find the equation. Another form is ax plus by plus c equals 0. That's the general form. And we can have vertical lines, which in general have the equation x equals a number, and horizontal lines, which in general have the equation y equals a number. Now, while in all these problems, m, it's written, or we can figure it out, in the general form to find m, so to find them from general form, we have to solve for y. So if we solve for y, we get y by itself, then whatever number we have times x is going to be our slope. When we have vertical lines, which they look like this, right? This would be a vertical line. The slope, it's undefined. So m is undefined. While for horizontal lines, which they look like this, the slope, it's 0. Let's say we have this problem. We have 2 points, A of coordinate -2, 3, and B of coordinates 4, 5. What can we do with them? So at the beginning, I'm just going to write on top of -2, x sub 1 and y sub 1 on top of 3, and x2 and y2, because that's going to be helpful. So let's see a few problems. So first of all, let's find m. So to find m, let's write the solutions here. To find m, let's use the formula y2 minus y1, right? y2 minus y1 over x2 minus x1. So 4 minus, and be careful, x1 is -2, so it's minus -2. So it's 2 over minus -1 times -2, it's positive, so it's 4 plus 2. So we have 2 over 6, which is 1/3. We found the slope. 2. Find the equation of the line that is passing through AB. Well, if I have the slope, which we found it's 1/3, and a point, which is of coordinates -2, 3, we can find the equation of the line using one of the formulas, which is point slope form, because we have those. So it's y minus y1 equals m times x minus x1. So it's y minus 3 equals 1/3 times x minus x1, which is -2. So be very careful with the signs. So y minus 3 equals 1/3 x, and then negative times negative, it's positive. So 1 over 3 times 2 plus 2/3. I'm going to add 3 to both sides, and y equals 1 over 3x plus 2/3 plus 3 over 1. We multiply by 3, and we get 2/3 plus 9/3. It's 11/3 plus 11 over 3. This is the slope-intercept form. This one It's point slope form. If we multiply this equation, y equals 1 over 3x plus 11 over 3 by 3, we are going to get 3y equals x plus 11. And if we subtract both of these and we move them on this side, we get negative x plus 3y minus 11 equals 0, or x minus 3y plus 11, you see how I changed all the signs, equals 0. This would be the general form. Okay, now let's do the third part, graphing. So let's graph A, which is of coordinates negative 2, 3. So this is A. And B, it's 1, 2, 3, 4, 5. So this point. So now let's connect them. A and B. So, we have graphed it, and part 4 says write the equation of a function. So we know that the function notation is f of x, and we would want to actually substitute y with f of x. And which one of these relations that we have here, this one, or this one, or this one, has y by itself already set up? The second one, right? So we can say f of x, so we go here, and instead of y, we write f of x equals 1 over 3x plus 11 over 3. And we wrote the equation as a function. And we know we can write it as a function because this graph that we drew here passes the vertical line test. Now, let's see what else we can do with this information that we did. Now, if I extend this graph, I see that it intersects the x-axis. So this point is the x-intercept. I also see that this point here, it's the intersection with y-axis. So that's y-intercept. Can we calculate them? Yes, we learned in the previous video. And to find them, right? So to find x-intercept, we set y equal to 0. Now, which one of these three, 1, 2, 3, is the best to set y equal to 0 and calculate the x? Well, the best one is the general form. So I'm going to use x minus 3y plus 11 equals 0. And I'm going to set y equal to 0, so we get x plus 11 equals 0, which means x equals negative 11. And does it make sense to get negative 11? Does this point here that we got make sense to be negative 11? Yes, maybe I didn't draw it on scale, but it is on the negative side. It is farther away from negative 2, so I might be on the right path. Now to find y-intercept, we set x equal to 0, right? In some problems, it's easy to read from the graph, but here is not, so that's why we do it analytically. Again, in the general form, in this one, we're going to set this time x equal to 0. So we get negative 3y plus 11 equals 0, which means negative 3y equals negative 11, or y equals 11 over 3, which is what? Approximately 3.920, so maybe 3.7. So does it make sense to get 3.7? Well, we got more than 3, right? 3 was here, and we got more than 3. What else can we do with information like this one? Well, starting with these 2 points that we had here, what else can we do? Well, let's see. Let's make this problem 6. And let's say, find the equation of a line parallel to AB that passes through 0, 4. So let me first take a look. How does that look graphically, right? So I want the line to pass through 0, 4. Where is that point? 0, 4. 0, 4 would be here. and it's parallel to the line that I have as my AB. So I want the equation of that. How do we calculate it? Well, the line parallel to AB is going to have the same slope as the AB. Now, looking at slope-intercept form, which is the one that we have as at number 2, the slope would be 1/3. And the fact that it's passing through 0, 4 tells me to use the point slope form, or in this case also slope-intercept form, because 0, 4 means is the y-intercept. So basically y equals mx plus b would be a contender for our problem. So y equals 1/3x plus 4, and we found the equation of this blue line. Now, just because we had this 0, 4, we were able to use this formula. If it was 1, 4, then we would have had to use the point slope form. Now, let's try another problem. Let's try to find the equation of a line perpendicular to AB that passes through the point -2, -4. So first, let's take a look how it looks like. So it passes through -2, -4. So -2, -4 would be this point. So it passes through this and it's perpendicular. So to be perpendicular, it should look, well, not really like that. Let's make it like this, perpendicular. So we want to find the equation of this purple line, right, to make 90 degrees. So how do we do that? Well, first of all, the slope of AB was equal to 1/3. So the slope of the perpendicular line will be opposite, so negative, and reciprocal of 1/3, so it's going to be 3/1, or -3. So the fact that it's passing through -2, -4 means we have to use the point slope formula, which is y minus y1 equals m times x minus x1. If you write formulas many times, they tend to stick. So y minus, this would be x sub 1 and this would be y sub 1. Y minus -4 equals m, which is -3, times x minus -3. So we have a lot of negatives here, so be careful. Y minus -4 means y plus 4. -3 times x minus -3 means plus 3. So this would be the formula in the equation in point slope format, but we'll go even further and open the parentheses, subtract 4, and get y equals -3x minus 13. This would be the equation of the purple line. Well, of course, the purple line, it's also perpendicular to the blue one, right? Because the blue one is parallel to the line AB. I do hope this helps.